Thanks, everybody, for coming here. We're here to talk about longevity. Everybody wants to live longer. We also want to live healthier. I know I do. I would love to live longer, but I want it to be a good life. So we're going to talk about those differences and how businesses are approaching that. We've obviously got a great set of panelists here representing different aspects of health tech, from drug discovery to drug development to personal tracking through the ŌURA ring with Tom. So I'm going to start with Tom, actually. Can you just actually help us break down this term, longevity? Because I've been in tech journalism for more than a decade now, and for a long time we talked about health tech. Now we're talking a lot more about longevity. What is longevity?
Well, longevity is a great product because, of course, everybody wants it, but you don't know if it works until you die. So it's the kind of thing that actually lends itself to snake oil salesmen, and has for a long time. I think the word longevity really breaks down to a couple of ideas. One is that you should actually live a longer health span versus lifespan. Who wants to live to 100 if you're on a walker and can barely talk? It's a terrible life. Mm-hmm. But it also has to do, honestly, with the quality of life. We kind of think about something like, live fast, die old, or try and age better, be graceful. And I think it's really about kind of the community and life that you can form around yourself. So it's really about, are you living a good life? Mm. And then, of course, the last thing is health. What's the status of your body? Are you healthy?
Mm. Greg, at Juvenescence, you guys are involved in drug development. And
yes.
so you're deep in the middle of this. And I just want to say, by the way, huge kudos to Greg for showing up today with laryngitis. So for powering through this. But just tell us, to what extent are there even any drugs on the market today that you would call a longevity drug?
It's really interesting. It wasn't meant to be, but it fundamentally is, and that's the GLP-1s, Ozempic, Mounjaro. Not because they're slowing cellular aging, but because they're decreasing your chances of dying of a multitude of diseases, neurological disease, metabolic disease, cardiovascular disease, and even addiction, which is really fascinating, that works on that. So that's there. It's fascinating for us who are trying to create drugs in that sector, because it defines how the model will look. These are going to sell $100 to $150 billion a year. So if you can add 10 healthy years, to Parmy's point, and get the longevity that Tom was speaking about, you have something profound that's going to drive a huge market opportunity. The second one, which is really fascinating, but we haven't figured out yet, is a drug called rapamycin. And we don't know the dose, but in the dog studies done by Matt Caberlin at Washington University, he's had profound results in extending the life of dogs. But we don't know the dose yet. And we know that it works on one of the major pathways of anti-aging. The other thing a lot of people are trying to do is rebalance, is to give you extra NAD or extra sirtuins, which are also pathways of aging. But what seems more sound scientifically is to bring them back to a normal physiological level, as opposed to trying to boost them too high. I want you to get a drug that drops you when you're 60 to the metabolic status of somebody who's 30.
Yeah. Moving on to Alex, your company Insilico is involved in drug discovery. You're obviously using AI in drug discovery. We can talk a little bit more about that later. And you guys have done some pretty amazing things. You've sold $3 billion worth of drugs to pharma. 10 of the drugs you've discovered have reached clinical trials in humans. So let's talk about the types of diseases you're actually tackling, because for you guys, your North Star is longevity, but to what extent are you focused on just treating prevalent diseases?
So, sure. I am in longevity for 21 years. I'm religiously focused on that, so that's the only thing I care about. However, over the 21-year period, I've seen a lot of startups come into this world and then die. So far, nothing succeeded in longevity. Everything failed. We run a conference in Copenhagen where 180 speakers speak every August, and we have about 60 startups. So it's a graveyard. And it's not a new field, by the way. So since the 80s, people are trying to discover drugs for aging. If you are going to go directly after aging, you're going to fail, most likely. So you need to develop a sustainable business model where you're going after age-related diseases with maybe dual-purpose targets, dual-purpose therapeutics that may work on aging, but have to work on a disease. So you do a proper clinical trial, After conducting the entire preclinical pathway, so it takes you 5 years to get the readout if you are very fast with AI and also with China. So we also piggyback on China quite a bit for clinical trials and preclinical development. And then sell those drugs to pharma, and then try to see if those drugs confirm your anti-aging hypothesis in a proper human clinical trial. So far, again, everything failed. Even rapamycin, we don't know if it works. GLP-1, we don't know if it works on aging. Believe it or not, nobody tested in a big clinical trial in phase 2 the aging clocks. So the idea
we just
is,
assume that it does. I mean, this is
well,
Greg's point.
we assume, but that's why we have clinical trials. So when the clinical trial is complete, you know that it works. Otherwise, it's just, do what your mother told you, plus a little bit of hope. So people also have religion, right? And they believe in, all kinds of things, which is a good thing, maybe. But you shouldn't believe in a drug unless there is a clinical trial confirming its safety and efficacy. And currently, nothing, absolutely nothing, is proven to work in aging. Except for DYMT, do what your mother told you.
So you heard it here. There are no silver bullets, right? There's no fountain of youth. And I think that's spot on. I want to make a comment about GLP-1s because I think it's really important to understand that there's like a biological kind of process that GLP-1s do. But what they really do is change behavior. And this is what you're saying. Do what your mother told you is like, to live well and to make the right choices and to make the right things about what you sleep, what you eat, how you exercise. Those are the things actually that are both the predictors and the drivers of both a long and healthy life.
Yeah, well, funny you say that because on the drive up here, I listened to a podcast in which the author of the book Blue Zones was talking about how it's got nothing to do with behavior nudging. It's actually all about your environment, and we've got to change the way cities are planned to encourage people to walk more and to buy more fresh produce and so on and so forth. Presumably, you completely disagree with that.
No, completely disagree.
Okay.
I think there are certainly environmental factors that are sort of, call it pro-longevity or pro-health. And by the way, sometimes you can imagine that those are wonderful vacations that you take into blue zones. There's a lot of holes with the blue zone data as well. Right? I mean, some of the things like the record keeping in blue zones is terrible. So they actually don't know if anybody's died. So they assume they're born, but they haven't died, and so they assume that they live a lot longer.
Again, this comes down to measuring success.
Let's not overplay the blue zones. I think it's probably true that if you eat a Mediterranean diet and live in a warm climate and take naps, all those things are going to make a difference in terms of your life. However, if you think about the things that are going to kill you, right? 20% of them roughly are going to be genetic. You might have a bad ticker, whatever. Choose your poison. 20% roughly are going to be environmental. You might be exposed to some kind of either poison or an illness. Most of the things that are going to cause all-cause mortality are behavior-based. It's heart attacks, it's diabetes, it's Alzheimer's, it's Parkinson's. These are things that you can affect with choices that you make every day of your life, along the course of your life, and will prolong your life and prolong the quality of it.
Greg, do you agree with that? This is coming down to do what your mother told you again. Is it all about that?
Well, there's a couple of aspects. One, to slightly refute what my honorable colleague said about the GLP-1s. If you lower your chance of heart disease, which is a lifestyle, if you lower your chance of neurological disease, you are going to live longer. Whether it's going to work for the people in Hollywood who are trying to take semaglutide to lose 2 pounds for the next movie, don't know about that. But if you're obese or you have diabetes or overweight, it's a profound drug. And also it's a profound effect on addiction. So we're going back to the lifestyle elements of this. As we got into it at Juvenescence, and with my colleague Jim Mellon, and we were beginning to look at the drugs, we realized how incredibly complicated it is. There is no silver bullet. It's going to be tweaking a lot of things. It's going to be personalized medicine, and we are so far away from that. But to try and give somebody 10 healthy years of living, an extra 10, that's completely viable.
Doable.
Yeah, number one is lifestyle, and we were going to talk about that. Exercise, far and away number one. Walter Bortz, former head of gerontology at Stanford. You are mentally or physically affected by exercise. You decline at 0.5% a year, mentally and physically, if you're fit, 2% a year if you're unfit. That's a heck of a delta.
Wow.
And then the other aspect, obviously, nutrition, sleep, and the things you all know. And so those things, but I do think we're going to find drugs that work on certain pathways that accelerate or slow down aging.
let's kind of keep on this topic of behavior change, because you run the company that sells the ŌURA ring, and it goes on your finger and it tracks. It's got sensors. I wear a Garmin. I track my steps, my runs, all those sorts of things. This is an industry that's been around for more than a decade.
Yeah.
So and everybody's been trying to figure out how to do these behavioral nudges through the device, through the app, as effectively as possible. What are kind of the key learnings that companies like yours have learned just over all these years? What actually works?
Yeah, I mean, I think of ourselves not in some tracking business, but in a behavior change business. I think there's probably three things that we've learned. One is frequency of use really matters, and actually having a cadence. And that's why sleep is so powerful, because sleep is the one thing that pretty much everybody in this room is going to do in a 24-hour cycle. And how you do it actually has a profound feedback loop on how you feel the next day. So if you can adjust your sleep, I think we all know, if you have a good night's sleep, you're going to be like, wow, the next day, better. It's a really strong feedback loop. So that's frequency. I think the second thing is really understanding the impact of your behaviors. And the thing is that most of us know if we drink 6 tequilas that the next day is going to be a bad day. We can all pretty much predict that. Or if we're super sick, like there's things that your body tells you, right? Nod to your illness. I hope you feel better. But the thing about like what's on the margins, and before, we call it giving your body a voice. Before wearables, you actually didn't really know what was happening to your body when it was on the margins. You couldn't quite perceive the delta between slight, maybe call it a sip of tequila and half a tequila and 6 tequilas. You know the extremes, you don't know the margins. And the thing is, like, the power of something like ŌURA is that it's on your body all the time. It's measuring you at night, which is actually when your body's at rest. You can get like a really clean signal, unconfounded by other factors like what you're doing during the day and running around, all that stuff. You get a really clean signal, so you can see these small deltas, and those small deltas, that's where the meaning is, right? A quarter of a temperature incline, a slight increase in your respiration, a decline in your HRV might be the onset of an illness in 2 or 3 days. You don't know that. You're not feeling that. But that data on the margins is what matters. That's the second thing. And then I think the third thing, honestly, is like this kind of, we're all the CEOs of our health journey. We're all making experimentation around how do we improve it. By the way, we're the best judge of that. And also, like, we're all different. What might work for you or you or you or you is going to be completely different because of the complexities of our genotype, phenotype, behaviors, lifestyle, health factors, all those things. And so what something like ŌURA does is it encourages you to experiment with something and then find what works with like an experimental outcome, which is objective data.
I'd like to, at some point, we're going to just touch on AI and how you're using that to make sense of all that data, because I think maybe one of the problems with health tech and wearables in the past has been, yes, I'm so in with the quantified self movement, but I'm drowning in data and I don't really know what to make of it.
Who has the time?
Yeah, right. But just really quickly, Alex, I wanted to just go back to one point you made. I have to ask. You said there's this graveyard of anti-aging startups. What did they do wrong? All these other startups that have approached this issue.
So I actually provided an online free course on that, Investing in Longevity 101, so you can actually read it because we have a lot of case studies. So some people thought that biology is easy, and biology is not easy. Some people thought that the drug is going to come without a side effect, and everything comes with a side effect. Even rapamycin that we're talking about, currently people who were pushing rapamycin are some of the most active advocates. They died of cancer. Some of them of very aggressive cancer. We don't know if it's a cause and effect. That's why you need clinical trials, long-term clinical trials, because everything comes with a liability, except for one thing. If you are doing psychological aging exercises, something that actually I published 4 papers on that serendipitously. We've developed a psychological aging clock and ways to reverse it. So read some of the papers. That's free, right? And that's why you need, people like Brian Johnson who can explain to people that, their biggest enemy is age. We're getting into the world, we're now getting body positivity-like stuff in longevity where, I'm comfortable with my age, I love my age. Great. What's your biological age? And a lot of companies thought that, advocacy or large A rounds, B rounds will help them go through this complexity of biology. And they thought it's about funding. It's not about funding. So you need to make sure that your business is sustainable. Because to develop one drug to the market, like GLP-1s, you know how old they are? 42 years.
Yeah.
So from target discovery to the actual medicine for obesity, 42 years. Novo Nordisk did the work, and Eli Lilly. Pfizer was there first, and they decided to close the program. So if you learn
Big
about
mistake.
those, that's like really
World-class
crazy.
mistake.
Yeah, and reasonably they tried to recover,
New CEO.
like your beautiful anti-aging GLP-1, right? Let's stay on that, right? Even if you were to develop that for longevity right away, you wouldn't be able to do it. Why? Because 40 years from target to the molecule to clinical trial to approval, and now we still don't know if it's reversing any aging clocks. So on Brian Johnson, it won't work most likely because it actually causes muscle wasting.
Yeah.
And age-related macular degeneration is correlated with that as well. So it comes with a lot of liabilities. If you're obese, take it. If you're not, then you might be, if you're that venturous, why not take an anti-amyloid antibody for Alzheimer's, right? You take it once a year and forget about, if you believe in amyloid hypothesis. But if you were to develop a GLP-1 inhibitor agonist right now for longevity, you wouldn't be able to pass it through clinical trials. Pfizer tried to recover their kind of early leadership where they decided to abandon GLP-1, and they tried to do a small molecule recently. One patient out of 1.4 thousand people in a phase 3 clinical trial showed liver enzyme elevations. Liver enzyme elevation, I get it all the time. The trial was killed, and they managed to, they lost several $1 billion.
Wow. Greg,
Yeah.
do you, it sounds like there's just a bit too much caution in this whole industry. Am I reading that right? Do you agree with that and with what Alex is saying when it comes to drug discovery and drug development?
It was interesting. Peter Diamandis is trying to put an X Prize together for anti-aging. And he brought a bunch of people together to try and figure out what to do. And I said, it's got to be a biometric panel. What we need is a great panel that tells you how you're aging, because nobody's going to run a 75-year clinical trial. Had they done that on the GLP-1s 42 years ago, had we had it? And if it is, and I have no reason to believe it is anti-aging, other than lowering your chance of dying of disease, that would have been instantaneous. You would have known, wow, we have something profound. These companies that have failed, what we have in a number of companies that have started in biotech, our main comment is fail quickly, fail inexpensively, and move on.
That's right.
And so give me that panel. It's not working, next product. Or do I need to combine it? So that's going to change everything, because first company that I was involved in, Medivation, from in the lab at UCLA, 2004, to on the market in cancer, 2012, 8 years. 2 years to get into clinical trials, and then to do the clinical trial. So it can be done. But we had a biomarker. And by the way, cancer trials are a nightmare because you need overall survival. So it's not like you can just test and see what the people are doing. You have to wait for them to die, which they call an event, by the way, so no one's offended. How many events have you had today?
Oh, no, that's horrible.
Anyway, back to you, Parmy.
But it's a product cycle that's measured in half a lifetime.
Yeah.
Right? It's very hard to
That's a good way
iterate
put
and
it.
improve the product when you're waiting around 40 years to see what the outcome is.
But surely the answer isn't as simple as let's just take the lean startup approach and iterate on the fly. This is like you can't just apply startup principles to this industry. It's a tough one. Let's just quickly talk about AI, because we have to, right? We're in the midst of the generative AI boom. From
Time to AI, 14 minutes.
It took us, we did it. We've got LLMs are kind of, everybody's trying to plug them into their companies and into their infrastructure. Obviously, they're going to affect some companies. This particular type of approach to AI, generative AI, will perhaps affect your company more than these two, but at the same time, also raising interest in other approaches to machine learning and perhaps boosting opportunities for you. But just to start with you, Tom, talk about how you have exploited generative AI, capitalized on it. Sorry,
I hope
that
we haven't
sounds
exploited
better.
anybody or anything, even if it's an AI. I will say also, I think that the drug drug discovery, actually, the impact of AI on drug discovery is transformative. In our much more kind of modest world of trying to change human behavior, 2 or 3 things that we've learned, because we did roll out something called the URA Advisor, and basically 40% of our users a couple of times a week will interact with it. And that's interesting.
It's like essentially
it's like a
chat bot.
It knows all your data. It has some guardrails. It has sort of a federation of AIs that know various things. It has some pre-computed facts. It can draw graphs for you. So the 3 things that I would take away from it is, one, this problem of, wow, there's just too much data. I can't make sense of it. I don't have time. I'm out. Right? And that, like, asking the system, say, hey, how's my sleep been? And it goes, here, I'm going to draw a graph of your sleep. It's kind of useful, because then you don't have to parse or navigate some complicated user experience to gain some insight. So that's the first thing. The second thing, maybe less profound, but maybe more interesting, is that people want to have a relationship with this thing. So we've noticed this because we were like, well, that's interesting. Let's study it. And we got a sort of a focus group. The first thing we noticed was, well, I asked the audience, men or women use it more frequently? What do you think? Take a guess. Just show of hands, men. Okay, all the men raise their hands. Women use it twice as much and twice as long. And we were like, wow, that's not a random event. That is a pattern. And when we talked to women about it, they said, well, actually what we like about it is that it's infinitely patient, infinitely empathic, knows everything about us, and is willing to talk to us for long periods of time.
Perfect relationship.
Unbelievable. And I mean, I'm making a huge generalization, but this is what the women were saying to us. And then to sort of play on this out, we said, well, what's the feature you want us to add to it? Is it like, do you want us to remember things between sessions? Do you want it to make it more personal? We said, actually, what we want to do is be able to name it.
Oh my gosh!
Right? We want to name it. We want to have a relationship with this thing. And by the way,
deepen that relationship.
We can go a whole different direction, which is, I think the power of AI actually is kind of increasing the amount of interactions that people have that are simulated human interactions, but actually are meaningful, or maybe will change their behavior. So that kind of gets to the third point, which is that if you use something frequently enough and you trust it and it knows you, the properties of a good coach or doctor is that it cares about you, and it knows about you, and by the way, it has something to say that might actually benefit you, and you're like, oh, you know what? I might actually do that. It's do what your mother told you, but translate it into some kind of like simulated digital experience. And I think those 3 insights for us a little bit blew my mind, because, whatever, people are adding AI to stuff, and it's kind of bogus. Like sometimes it's just like, wow, that's really not that helpful. Sometimes it's extremely helpful. I think in this case, we're scratching at the surface of a transformation in the way care is delivered, which is that there are not enough doctors on the planet to give enough time to all the people who need help, let alone the sick people. What about all the people who are not sick? You're trying to influence their behavior. And I think the sort of AI-type interactions, call it the doctor in your pocket. Everyone's got a wearable on their body. Everyone's got a supercomputer. And then the doctor saying, hey, Tom, do this, or don't do that, or can I remind you, or I noticed you were doing this. And those nudges, I think, if they're contextual, they're trusted, they're accurate, they're effective, that's what changes behavior. And we've seen it because we've seen what URA can do for people's behavior. People sleep better, people drink less, people are more intentional about their exercise and their diet, and those things have outcomes, as we just were discussing.
This is the thing that I find wild about AI, is that, 20 years ago, science fiction writers were writing about AI as being this kind of encyclopedic, robotic type entity.
Literally the worst person you want to spend time with.
Yeah. But today they're actually not great with facts, but really good at empathy and compassion. And so it strikes me you guys must have a lot of behavioral scientists and psychologists who are trying to find ways to, not exploit, capitalize on that.
Not even capitalize. I mean, we're there for our users, trying to make them healthy, and that's the outcome that we're after. The last point I'll make, and then we can go off on another tangent, but the last point I'll make is that I think the user interface for AI, right now everyone thinks of it as a chatbot, right? Which, by the way, super time consumptive, it's very linear. You have to do a lot of the work. What's the query I want to ask? It's like you have to do it. I think where this starts to change is where the AI reverses the polarity of the user experience and starts to present you with information in context at the right time when you have the ability to consume it. And that polarity reversal, actually, I think is going to be kind of like, we're going to see it across lots of different interfaces and apps. It's going to change the way people interact with it.
Yeah, it'll be interesting to see how Johnny Ive figures out how to do that for OpenAI. And in context at the right time is important, because I know people who have the Garmin and it tells them at the worst possible time to get up and move.
You're sick on the couch, and it's like, you got to finish your steps today.
Greg, tell us about how, has there been any impact on your business just from the AI boom?
Yeah, absolutely. We just got a major investment into our company, because part of it was because we acquired an AI company. AI is very, very good at chemistry, so the drug discovery element. It's currently rubbish at biology, because biology is chaos theory, and the computer's not there yet, but it will be, and then it'll be extraordinary. But it's going to be really intriguing to clinical drug development. Obviously, Alex has used it very well to find a variety of products, 3 billion. And so, dollars worth, 10 products. So, in a cancer trial, you're allowed to have a readout partway through. And usually it's like 8 to 12 months. And they call you up and they say, you look at it, yes or no, you're going to need to continue the study. There's not enough differentiation. AI could tell us in 1 month.
Yeah.
Suddenly you go from a 7-year, 8-year program to get your drug approved to like 3 or 4 years, saving millions of dollars of money that's expensed, which I think is over $1 billion per drug now that we expense. So yeah, it's going to have a profound effect on it. And the other problems, particularly if you're doing, because mental health is a big issue, anything to do with psychiatry, you have such a huge placebo effect.
Yeah.
And this AI should be able to mitigate that as well.
Okay. Alex, AI has been fundamental to your company from the beginning, so it's not like you guys just jumped on in the last couple of years.
So our company was actually founded at the NVIDIA GTC conference, right? So my talk was, can NVIDIA solve aging, 2014. So first 5 years were purely algorithmic, and I must say there are several people in this conference that profoundly influenced us, and we would not survive without them. Jim Mellon is one of them. He actually made money on us. Thank you. So somebody made money in longevity and helped us a little bit. Also in 2019, we published something that is truly revolutionary, I'm very proud of. It's a paper in a journal called Nature Biotechnology, where we, for the first time, utilized the algorithm I developed called generative tensorial reinforcement learning. That's 3 years before ChatGPT. And at that time, it was pretty novel. So basically, you have the generative system and the reward and punishment system for the generation of novel chemistry with the desired properties. So instead of looking for a needle in a haystack, you generate perfect needles for novel targets. So in that paper, we showed that within 21 days, I can synthesize just 6 molecules. Within 46 days, we can go to a mouse and test it. So that paper spent almost a year in review. It would not have been published, actually, without the help of Stefan von Holzbrink that I met at this conference. He basically told the editor, saying that, look carefully at that. It's the most famous paper that I have now. And if you're interested in continuation of this story, last week we published a paper in Nature Medicine showing that we have completed the phase 2 trial in idiopathic pulmonary fibrosis. That's an age-related pulmonary disease where you lose lung function, so you lose lung capacity. And on our drug, we show very promising dose-dependent recovery of lung capacity for the first time. Everything else slows it down. And within that study, we also did proteomics analysis. By the way, we had to fight with my clinical team to include proteomics data because nobody cares about that. The primary outcome measure is forced vital capacity. That's how pharma does it. That's why GLP-1s do not have an aging clock with them yet. And we have done this proteomics analysis. Now we gave this proteomics data to several labs so they can do proteomics aging clock on my drug within the clinical trial setting. And we're submitting this results now to a very high-profile journal because it looks like we have reversed the aging clock. No claims yet. But basically, you develop a drug for a disease using AI. It helps you shorten the cycle dramatically. So we did it within 5 years, from 0, novel target, novel molecule, phase 2 complete. And aging research comes free. So basically, you are developing a drug for a disease. Sometimes we develop drugs for like hardcore breast cancer, but the protein target is also implicated in aging. So maybe usually those females that get that breast cancer are like 60 plus. So you can actually see maybe they are also getting younger. So that would be a really cool bonus.
Just quickly, Greg, I wanted to give you a chance to talk about one of the drugs. You've got 2 drugs that have just finished human trials that are really interesting in what they've been able to do. Maybe if you just a couple minutes and then our last question.
So The Amish, religious sect in the United States, specifically in Indiana, won't get in a car, won't get in an elevator, but have a hemorrhagic disease, so they got their genome tested. And there's a gene called SERPINE1, as you spoke about genes, Tom. And if you have a certain form of it, you get the hemorrhagic disease. If you have the heterozygous form, you live 10 years longer than everybody in your community.
Wow.
And the interesting thing with the Amish is they do everything together. Eat, sleep, do. So you got the perfect placebo-controlled study. So University of Michigan looked at it and found that they knocks down a pathway called PI1. So we licensed the drug, Juvenescence, to see if we could do that. We just finished the first human trials. My great concern, to speak to what Alex said, is that it's going to have toxicity. If it doesn't have toxicity, it's very important. We can measure PI1. In the phase 1 clinical trial, you will know whether it is working. So all of a sudden, that cycle of 8 to 10 years gets diminished dramatically. And it was interesting because we've just done a profound deal in the Middle East with Juvenescence, and we met with the Department of Health. And they have the most comprehensive biobank, diverse biobank in the world, 700,000 people. Not only their genome, but also their medical records. It's profound. And we were sitting down with them, and we were presenting to them, and their head of research jumped up, started looking at the screen, and he goes, "We can confirm that PI1 is a biomarker for aging." He said, "We've done enormous studies. It also plays a big role in chronic kidney disease." So we're fortunate, like Alex is with IPF, you can go after the chronic kidney disease, CKD, you can go after fibrosis, because it's a very potent antifibrotic, and then back into anti-aging. So
It's the root to anti-aging.
yeah, so hopefully we get that biometric panel, that would rapidly, within a year of testing, say, this is working.
Yeah. Wonderful. It sounds like from what we're saying, I was shocked to hear it was 40 years for GLP-1s development. But with the developments that we've had in AI in particular, we're shortening that lifespan potentially. Okay, last question, because as I said in the very beginning, we all want to live a bit longer and a little bit healthier. At least some of us do. So I'll go around to each of you, and you could either say how you do it, what's your advice, what you do to help stay healthy and live longer, or what would be your advice to people here to do that? Let's start with Tom.
Well, sleep better, drink less, eat better foods, and strength train.
Strength train. You feel like that gets kind of neglected a little bit.
Well, actually, I think
it does.
in longevity circles, I think everybody's come right back around from cardiovascular exercise. That's sort of really about exercising the heart and lungs to actually building muscle is one of the key determinants of being able to have like autophagy and things that will promote longevity, but also higher quality life because you're better muscle tone and you can get around, you can do things, you can have a better life.
Yeah, that's a good one.
Riffing off what Tom said, one of the big ways people die are from falling. So that muscle strength is really important. I would say the optimum exercise program that I've seen in research is a mix. A little bit of high intensity. You've definitely got to have some endurance training, yoga or Pilates, get the stretching. And one that I don't think women do enough is the weight bearing, which prevents osteoporosis or at least diminishes it. And then there are some very interesting studies coming out on supplements. You can probably ask Brian Johnson if you can catch him for a minute on what supplements are the best. But omega-3's had really interesting
Omega-3, okay.
Vitamin D3 has come out. There was a study done at UCLA in 2018. They put people on 2 drugs and 3 supplements, and they, according to DNA methylation, they reversed their aging by 2 years. In 1 year, it reversed aging, which many people say that's escape velocity for us. The one that's shocked me in the probably last few months is creatine.
Yeah.
Okay.
Yeah, creatine's hot.
It's not just the muscle, that increases muscle mass, but it also has thank you very much. As Tom said, it helps his brain and the rest of yours as well. So it's coming quickly as we begin to do the proper assessments as to what can profoundly change how you age. Methylated B vitamins, by the way, if your homocysteine is up, will lower your chance of Alzheimer's by 30%. So there's a bunch of things that are really compelling.
Okay, taking notes on all this. Go on. Alex?
What's left?
I think from 26 years old to fairly recently, I was kind of like in the closet Brian Johnson, so also was trying all kinds of stuff. And lived on like 100 different supplements, including creatine for many, many years. I think that currently there is no evidence that anything works better than, do what your mother told you, DYMT.
Wow.
Unfortunately, and many of those supplements, they have significant liabilities. Even creatinine will screw up your kidney if you aren't careful. Or if you have early stage submucosal cancers, it will accelerate it so much that it's going to be super deadly. So what I do is I do aging research. So right now, the best thing you can do is invest everything you've got on longevity, because so far we've got so many people investing in weapons of death, and so few people investing in weapons of life. So you need to have more people and champions who are focusing within the traditional paradigm, within the realm of credible. So lots of academic publications, lots of conferences, clinical trials. You need to invest in that. You need to invest everything you've got in that, because the most important asset you've got in your life is your life. You lose it, you're done. So I basically 100% committed. I think that if you want to do two things that are reasonably effective and are kind of risk-free, so you basically are a venture capitalist of your life and you want a government bond, preferably the government that is not overspending. So you want to get two things.
Yeah, I have no idea.
One is psychology of aging. So that is the most plastic thing you can do. So you basically, there are several features you can very easily change, and you're going to feel very young. And you're going to behave as a younger person. Second thing you can do is ultra-detailed diagnostics. So you need to ensure that you don't die of something stupid, as Peter Diamandis likes to say. Because it's so easy to get something stupid and die of something that is easily fixable. So if you get even pancreatic at stage 1, it's just nobody catches it at stage 1. You may be able to fix that. If you have it at stage 3, you're dead within a year. So you don't want to have that. Or some submucosal, gastric cancer that you can detect using a biomarker. So a couple times a year MRI, very comprehensive biomarker panels, and ensure that you don't do something stupid. So I think many of the supplements will actually screw you pretty dramatically. Oh. And yeah, you may want to think about how to get there. Even ultra optimization. Buddhist monks in high net worth environments, they live only 3 years longer than average. So you can optimize diet, exercise, sleep, meditation. No stress, you basically live to die. 3 years plus. And the number one determinant of your life right now is wealth. So you're already kind of there. Just don't die of something stupid.
Yeah.
We need to have effective medicines, and currently we don't have that. So the only way to get there is clinical trials, phase 2, biomarkers, showing age reduction and minimal side effects. We need another GLP-1 with aging biomarkers.
Brilliant. Thanks so much, guys. To Tom, Greg, and Alex, thanks for a wonderful discussion. Thanks to our audience.